the heck is an asymptote? It is the invisible line that the graph seems to make on its way to infinity or negative infinity. Right, makes no sense. So let me draw a bad picture. X and Y axis. Say you have, oh, I can do colors. Hold on. Say you have this graph, this function, which you can see, and you have this going on here, and this going on here. The asymptote is this. Okay, the asymptote is where the graph seems to go when X is getting really large or it's going to infinity or negative infinity. So on this one over here, this guy, when X gets really large, way over here, it seems to be flattening out on, what this is? Let me say this is 1. X is going to 1. And that's how you write the asymptote thing. You don't put asymptote equals 1. You put X is 1. So X is getting really close to 1 when this goes to infinity. Maybe this also has a vertical asymptote. Okay, on this one, when X is getting really negative towards negative infinity, I'm getting close to 3. So Y is 3. It's kind of like a way to see what the graph will look like when X gets really large or really small. Okay, I'm only gonna do the vertical ones because the horizontal ones have all kind of rules where you gotta look at the degree and then you're gonna match if the numerator matches the denominator. If the numerator is bigger than 1 or less than 2, we don't have time for that. It's not that serious. Maybe another time. You know what? Yes, another time. But for now, I'm just going to do the vertical asymptotes. Okay. So the way you check the vertical asymptotes is you look at when X is getting really, really big or really, really small to see. You try to make the denominator 0, basically. So if you can factor, you factor. Let's see. Let me check. If you can factor, you factor, and you're trying to make the denominator 0, but not the numerator. So in this one, what can we do to make the denominator, the bottom part of the fraction, 0? When X gets really, really large, like say X is 10,000, then you're gonna have 1 over 10,000, which is basically nothing, plus 3. Who cares about 3 when you're in the 10,000s? So the whole thing will be 0. So my asymptote happens when X is 0, or my asymptote gets close to 0 when X gets really, really large. When X goes to infinity, the whole thing flattens out and becomes 0. Remember, I can call my function whatever I want, g of x, w of x, x of x. That would be weird, but I could do it. So what do I need to do to make my denominator a 0, but not the numerator? This is the same thing as 2 over x plus 2 twice. If I had a -2 here, then this whole term would be 0. And that would be my denominator being 0 without my numerator being 0. And that'll happen when x is -2. These asymptotes are so much easier than the other ones. Okay, q of x, because I can do that. I can call it whatever I want to. What do I need to do to make my denominator a 0, but not my numerator? I would need to have a -1 here. And that would give me a 0 on the denominator part. So the value that makes a denominator of 0, what they call the asymptote value. R of x. What do I need to do to make the denominator a 0 without making the numerator a 0? If I put a 6 here, 6 minus 6, you get a 0, sorry, for the bottom, the denominator. And then since I have an x term in the top, I have to check anyway, because I want to be sure. So 3 times 6, 18 plus 5, not 0. 23. So my bottom is 0 and my top is not 0. So my asymptote value is 6. That works. P of x. I'm going to factor. I want to factor my denominator because I want to see that I'm checking all the values. X minus 1 times x minus plus. I think it's been a while. I think it's all -1. Yeah, I think this is all -1. I'm not sure. It doesn't matter. Okay, what value is going to make my bottom a 0? I put -1. Because if I put, okay, -1 gives me -1 to -1 to -1. 0. That's going to be a -1, -2. It's going to be a +1. +1 gives me 1 times 1 times 1 minus 1 is 0. And then I check my top since it has an x value in it. So 4 times 1 is 4. So it's not 0, we're okay. So my asymptote value is 1. Not -1, because if I put -1 here, my whole thing is going to be -2, and that's not going to give me a 0. Okay, W of X. Okay, I'm going to factor because I don't know what's going on with this, but I want to make sure that I have the right 0. Because I have 4x minus 1 on the bottom, I'm going to hope and pray that that's one of the factors on the top why they have these ridiculous numbers. So for 1 times 7 is going to give me the 7. I have 8x squared, 4x, so I have 2x left. I need my middle term to be a positive, so I want the larger of the factors, the 4x and the 7, to be positive. So now what do I need to do to make the denominator a 0? It doesn't really matter because these cancel, right? And whatever I do, whatever number I put here, it's not going to be a real 0. It's going to make the top be 0 also. Because if I get a 0 on the bottom, then I'm going to have a 0 on the top. And I can't have that. So this one just doesn't have an asymptote. Because I can't get a true like 0 on the bottom only.